In this video, we will be discussing some of the latest mind-blowing technologies that are set to revolutionize humankind. These new technologies have the potential to change the way we live our lives and offer an insight into what the future holds for us. Stay tuned to discover more. Researchers at the Massachusetts Institute of Technology have developed a new fabrication technique for efficient muscles in tiny insect-like flying bots. Flying insect robots, or diminutive drones as they're known around campus, are an area of research that has been steadily growing over recent years, with many teams working on it full-time. They work by using soft actuators, which are similar to artificial muscles, but instead, they flap their wings rapidly under high-voltage chargers. This particular advancement needed much higher voltages, so the team turned to electroactive polymers, which are materials that change their shape or size when an electric field is applied. This new fabrication technique produces low-voltage, power-dense artificial muscles, which improves the performance of flying microrobots and also opens up other possibilities for applications such as soft robotics, prosthetics, and biomedical devices. Birds have been able to do what few robots can: perch on complex surfaces and grasp irregular objects. For decades, scientists around the world have tried but failed in their attempt at creating machines that mimic how these feathered flyers fly or land with such grace. Until now. A team from Stanford University's School of Engineering has created a bionic wing similar to the nature-inspired aerial grasper prototypes developed for search and rescue operations following disasters like earthquakes, where having something lightweight is necessary due to its size and strength. The result? The new design enables drones equipped with SNAG, an acronym for Stanford's Novel Aerial Grasper, technology to land on almost any surface and grab onto things in a similar way that birds do. The engineers at Virginia Tech have created a soft robot that can transform into any shape they need, like a land vehicle or quadcopter. The researchers used kirigami, the art of making shapes out of paper, to design an elastic material architecture for their repeating geometric patterns, which allows it to be morphed easily with no motors or pulleys necessary. Also, with this technology, it is possible to heal a broken piece by melting and reforming it. This process only takes less than 1/10 of a second from start to finish. At Northwestern University, engineers have developed a new smart sensor platform for face masks that is lightweight and tiny. It uses the wearer's perspiration rate, heartbeat information, as well as how often they change their mask to wirelessly transmit this data back into an app on your smartphone, allowing you to monitor health in real time. The feature can also predict fatigue based on previous patterns of its users' vitals, while keeping them up to date with any issues surrounding elevated heat rates or leaks caused by wear over time. The resulting product could potentially help to prevent the spread of infectious diseases and improve air quality for people who are required to wear masks often, like healthcare workers and soldiers. Using human cardiac cells, scientists at Harvard and Emory universities have developed a fish that swims with the same power as our beating hearts. The miniaturized circulatory system can keep navigating around in salt solution for more than 100 days. There are high hopes about this little device composed entirely out of tissue, and it could one day help people who suffer from rare disorders like angioedema or arrhythmia without having to go through surgery every time their symptoms return. When a team of roboticists turns their attention to creating an invisible army of 1 million microscopic walking robots that cannot be seen with the naked eye, you know they have taken on something new. The microrobots use innovative legs designed by this group of engineers at Cornell University in New York and are only about 0.1 millimeters wide, which means you would need many together to actually see them. Presently, the objective for the engineers is to program the robots, allowing calculation and independence. Upgrades could clear the way for multitudes of robot specialists inside our own bodies, fixing wounds or going on the assault against infections. That's it for today's video. We hope you enjoyed knowing about all the microtechnology that will spy on you in the future. Stay tuned for more mind-blowing technology updates.